Hello, and welcome to Robot Lab Live, coming to you live from the Bio-Inspired Robotics Lab here at Cambridge University. So I've got a timer on my screen for not very long at all, and we've got quite a lot to fit in at the moment. So not only are you about to see a robot chef that's been learning to cook scrambled eggs and omelets and to adjust its recipe after it's tasted its food, not only are you going to see a robot that's been helping out doctors to examine patients without even being in the room with them, but also we'll hopefully have time to answer some of your questions. So if you've got questions, if you've got comments for us, and if you've got a YouTube account, leave them down in the comments below. We can see them live, and we've got some time at the end where we can hopefully talk through some of them and answer whatever you might want to see. But before we get into that, I sort of just wanted to show you what it is that a bio-inspired robotics lab actually does. So here's some examples of some of the projects that we've been doing. Here's a hand which is learning to pick up objects without being sent any specific commands, so it's totally passive. Or here's a finger with embedded sensors that's learning about its environment while still being soft and flexible. We look at how seeds flutter to the ground from trees and how the shape of the seeds will affect that motion, how we can predict what that motion might be, where it's going to go, and a similar thing for dispersal on water as well, even how we can control some of that motion. And we've also had a go at harvesting some lettuce using robots too. Excellent. So yeah, we do cover a really wide range of projects, and that does include our robot chef. And hopefully Greg's currently down in the kitchen with a robot that has just started cooking some scrambled eggs. So Greg, I'm gonna put you on screen and it's over to you.
Good afternoon, everyone. Yes, I'm definitely in the kitchen with the robot, and welcome everyone to the first presentation of our lab. I will run the robot in the background and tell you about the project. So the project was to have a robot which would take the eggs you cooked the way you like and sample it, and then to actually try to teach itself to cook it exactly the way you want. So it works in a very simple way. Like we don't see now. But the idea of the project is it has a control loop. It would like cook eggs, test them out, and then it would run the control loop of cooking eggs and tasting them with the sensor over here. The sensor takes samples and then run statistics on it, which is telling you how much mixing you like, how much salt you like, was it cooked too fast, too slow, and we are showing that in the end it's a very good match with the previous eggs. We had one problem here, which was due to initial setup of the robot, but we should get going very soon. We should get going soon, so the robot should start with moving the pan to the hole which we use for cooking, which is over there. But then before it starts cooking, it will actually add amount of salt, which the current setup tells it to add, which will of course be adjusted during cooking. So after adding salt, the robot will move the pan back and start mixing. I will just help it a little bit by turning the heat on the setup we usually use, and we will very quickly see the robot cooking. So it's very interesting problem with the cooking because there's a lot of very messy components. It's not like steel components which you would handle when assembling a car. It's very much a lot of soft and complicated to understand objects like eggs, which we humans understand it very easily, but it's very much hard to program it to work. So we will just have a quick look about the initial phases of cooking. I can even speed up the initial phase. And then we will be back just in 5 minutes to see the effect of the cooking. I will pass back to our main streamer.
All right, thank you, Greg. And yeah, so we will be back in a minute to see those eggs once they're a bit more cooked. Yeah, if you've got comments, if you've got questions, leave them down below and we will have a go at answering them live, anything you might want to know. But in the meantime, I promised a robot that's been helping out doctors using a process called Teleoperation, where a doctor sitting at a screen away from the patient can send instructions to a robot in front of a patient in a different room somewhere else in the world, and that can return some real-time data to help make decisions and diagnoses. So to tell us a lot more about that, and on the other side of the room to me is Leo, who I'm going to add into the stream. And yeah, the floor's yours.
So hi, good evening, everyone. And I'm here to talk about teleoperation. As my colleague David introduced to you, teleoperation is the process of you controlling a robot that is operating in another environment. It can be to the other side of the world, or in our case, it can be on the other table. But the key thing is that we have the robot that you can see in the other screen, and you have a person, in this case me, controlling the robot through an interface that we can probably show if we add the third camera. Yeah, so you can see that is me, and you can see on my screen there is an interface which is basically showing me what the robot is feeling. We have a sensor on the end effector of our robot, and I can just use my keyboard to control the robot and press on, for example, that phantom that you can see on the table, right? If I press, you're gonna see that I basically have a representation of what the sensor is feeling. I can control this robot in any direction. And I can also, we have basically two different processes. One is the robot and one is on my computer running at the moment, and they communicate to each other. We can play with all the communication parameters. For example, we just finished a study on how the delay between what I'm telling the robot to do and what the robot is doing is going to affect my performance in being able to touch object and recognize object. Recognize the difference between different objects. We also can introduce some autonomy. So we can introduce some movement that the robot is going to do by itself. And those movements can be added to the movement of the doctor. So let's suppose that I'm a doctor and I want to perform a given task, but maybe I'm not precise enough. The robot can add some small adjustments so that the examination is going to result in a better outcome, in a better diagnosis. Yeah, we also have a lot of different phantoms. You can see on screen at the moment, you can see here an abdominal phantom. This is like a section of an abdomen with different organs inside. You can see some liver phantoms, which are resembling of the human liver. This is actually a 1-to-1 scale. And then some smaller phantoms that we use just to do object recognition, to see if people are able to distinguish different shapes and stiffness of different objects. That is everything by my side. And I just pass the line back to David.
All right, thank you. So I don't know about you, but I definitely want to see how well these eggs are cooked. So we're going to pass back to Greg and see what we can tell there.
Hello, everyone. So we are actually quite advanced in the egg cooking process. You may think they should be done by now, but we are limited with how fast we mix because we don't have a cage around the robot. So for safety reason, it must be quite slow. Therefore, we are also not doing too much heat, but definitely our eggs are starting to look like scrambled eggs. You may say from now, you may need like more mixing, less salt. If you showed your perfect eggs to the robot before, that would be taken into account, and the next cooking try would be hopefully adjustment towards your needs. Thank you very much.
All right, thanks, Greg. So I'm going to leave you on screen at the moment, but I'm also going to bring Leo back in on this camera here, so that we can have a look at some questions. So I don't know what to choose first. Let's go here. Greg, can a robot teach me to cook? What do you think?
Well, I think currently you need to learn, you need to teach your robot to cook. And to do it, you need to learn yourself how to cook. But maybe in the future, it could be possible that we have a teacher replaced by a robot. But it's probably few years from now.
All right, and yeah, maybe in a similar vein, but question for both of you then, here from Katie. What programming language are you using in order to control these, to get these arms to do this? I don't know, Leo first, which language are you using?
Yeah, I use Python, which is very helpful because the interface with the robot is super easy. Like you just use Python commands and the robot moves.
So I also use Python to control the arm itself. But if you also look here, there is a microcontroller which is controlling the sensor over there. And that controller is Arduino, which is programmed in like dialect of C. And of course, the ARM has its own firmware, which comes with the ARM, which I've got no idea what language is written.
Yeah, and we like our MATLAB as well, definitely in the lab. So next up, if we have a look at some other questions, how long until robot doctors are making the diagnoses too, for Leo?
So that's an interesting question because if you think about like the technical side of the problem, we could make diagnosis, right? Because like we are able to touch our phantoms and to get data, so we could run algorithms to actually detect inclusion or detect abnormalities. The problem with that is mainly, I would say, there is no current law that is gonna protect the patient. So if the robot makes a mistake and makes a wrong diagnosis at the moment, we are not able to basically have a person that is gonna take the blame for that wrong diagnosis. And that's the biggest problem with robot actually making diagnosis. But technically speaking, we could already do it.
Right. And got another question here that's come in from the YouTube chat. So let me put that up. And that's back across to Greg. So what do you think are the biggest challenges in making robots that are versatile enough to cook different meals? So it's not just eggs. I know you've done potatoes recently. I don't know if you want to mention that as well.
Yes, so there is so many challenges to make it work. If you think about even manipulations of the object a human do, they are soft, they may be dry or wet, you never know. You don't know temperature, so manipulation is one thing. Then there is like intelligence, which needs to be very adjustable to different things. When you are in kitchen, you would use a lot of heuristics to like assess if something will taste good or not. Is it fresh or not? And then like another very important thing is a feedback. So when you are cooking, you would look at your dish and like adjust your cooking, learn. And for this, we need intelligence, of course. A robot needs to understand it. and we have a large problems with it. Neural net may not be enough because you need a lot of data and because of another problems. So there is definitely changes both in hardware and in software.
And I think I'm going to add in just one more question to finish us off, which applies to both of you. So will this eventually put all chefs and doctors out of a job? Let's go to Leo first. What do you think?
I don't think so, mainly because we need expertise. In some cases to teach the robot how to do the task, in some cases to supervise the robot. And we already have in healthcare a lot of examples of surgery, for example, in which there are robotic surgeons, but by any means that stopped or decreased actually the need that we have of doctors, right? So the fact that a doctor can have an easier job doesn't mean that we don't need a doctor anymore.
So as coming to chefs, I think a lot of people preparing food could be replaced, but maybe in the easier task like preparation of like everyday food. I think it's very, very far away from like expert chef to be replaced. So it's more a way to leverage your knowledge of cooking rather than completely replace people.
Yeah, thank you. And I think we're going to leave it there. I'm just going to give us one final view of the eggs being scrambled there. But yeah, thank you for watching. We'll be back again after we've reset at 4:30. So if you missed the beginning, if you do want to ask any other questions, please do watch again. If not, you can flick between the 15 other universities involved in this. There's a lot of cool stuff going on. So do check some of that out again. But yes, thank you for watching and enjoy the rest of your day. Okay, welcome to stream number 2 of Robot Lab Live here from the Bio-Inspired Robotics Lab at the University of Cambridge. So we've got a lot to show you in quite a short amount of time. So coming up in the next 15-ish minutes, we've got a robot chef that's been tasting its food to improve the recipes that it's making, which is scrambled eggs and omelets. We've got a robot that's been helping out doctors to examine patients without being in front of them by streaming data back and forth between a doctor and a robot. And then hopefully we'll get a chance as well to answer some questions from you. So if you've got any questions, if you've got queries, comments throughout, leave them down in the YouTube comments below. If you're watching this on YouTube, they'll come up on our screen and we can have a go at answering them live. So yeah, please do leave something behind for us. Just before we kick off though, I'm going to show you what a day at the Bio-Inspired Robotics Lab looks like with some recent projects. So here's a passive hand that's learning to pick up different shaped objects without being sent any specific commands. Here's a finger with embedded sensors that's learning about its surroundings while still being soft and flexible. There's an example here of how seeds fall to the ground from trees and how the shape of those seeds affects the path they take, how they fall, how we can predict that. And a similar thing here for dispersal on water, whether we can even control that path. And then we do have a go at harvesting some lettuce with robots as well. Yeah. So yeah, we do have a range of projects here, including the robot chef, and hopefully downstairs in our kitchen at the moment, Greg is with a robot that has just started cooking some eggs. So Greg, I'm going to add you in, and it's over to you.
But it's starting very soon. So the overall project is to build a robot which would look at your cooked eggs. So you cook the eggs, you like them the most. The robot would use this conductivity sensor here to take a lot of samples of your favorite eggs. It would run various statistics like mean and variance of them, which should then give you a lot of information about how much you like your eggs mixed, how much salt you want to add, how much mixing you do when you're doing your eggs. And then the robot is attempting to cook its own eggs, which it needs a little bit help with by just turning on the heat for it. And then after cooking its own eggs, it tastes them again with the same conductivity sensor, with the same procedure, giving him information about the robot cooked eggs. And then we have quite a smart controller loop, which based on the difference between your eggs and the first child of the robot would adjust how much you mix. We may adjust heat, and we adjust at time we press the salt mill. And then after around, usually it's 2-3 iteration, we have eggs which are very similar to yours. And the purpose of the project is to make a robotic chef possible. And there is very many challenges to make it work. One of challenge is handling. So eggs are fragile, you need to break them in a certain way. Imagine handling something soft like meat, which can be hot, can be cold, can be wet, which is changing how you are grasping it a lot. Then you need to add quite a bit of intelligence, all the heuristics which you use to assess your cooking, which is usually telling you if you need to cook for longer or you need to add more spices and adjusting it to your taste. It's a lot of social knowledge you also need to cook, like what do you like, what spices you like, what spices your friends like. And then on the top, the problem is that robots are almost blind as comes to operation in the kitchen. And the reason is we lack feedback. The tactile sensors are not as good. They lack smell, which is very important when cooking, which is telling you a lot. You are also sensing heat, maybe with your hand or just with your body. You can then taste during cooking, which robot can do. And that's the problem we are trying to challenge in our lab. So the cooking will now take a few minutes. So I'm putting you back to David.
All right, thank you. And yeah, we will be checking back in fairly soon to see the eggs when they're slightly more cooked. But if you want to know any more about that cooking process, get any answers from Greg, if you leave us some comments, we'll go through some of the questions at the end and answer what we can. But before then, we're going to look at how robots can help out doctors using a process called Teleoperation, where a doctor sitting at a screen can send instructions across to a robot that's in front of a patient somewhere else, so in another room or another country, that can examine a patient and return real-time data back to the doctor to help them make any diagnosis they might need to. And so, yeah, to tell us a bit more about that, I'm going to add Leo to the stream here. And yeah, so you're...
David, good afternoon to everybody. I'm Leo, and I will be talking about teleoperation. So teleoperation, as David already introduced, is the process of having two different systems. One is the leader, and it's running at the moment on my computer, and is basically, well, as the name tells, is the leader of the operation, and the leader is going to control the follower, which in our case is that robot that you can see on the other screen, here. And in our case, it's also on the other table. But technically speaking, those two systems can be at the opposite side of the world, or even, you know, your robot could be in space and you could be on Earth just controlling it. At the moment, we are using graphical user interface to control it. That means you can see on my screen here, I am basically seeing what the robot is feeling, and I can control the motion of the robot with my keyboard. If I, for example, if I tell the robot to go down, you're going to see the robot is going to press on the phantom, phantom being the soft dummy under the robot, and you are going to see that now the screen is telling me that the robot is feeling something. Obviously, going from black to white means that there's more and more pressure. This is a very quite simple setup with a very intuitive graphical user interface that we can use on any laptop, and then can allow doctors to make diagnoses over long distances. We also have complete control over the communication system between the robot and the controlling laptop, and we have been studying the effect, for example, of delay in the communication. So how people behave when there is delay, which is commonly known as lag over the internet, and all sort of different behavior of the robot. We are also looking into autonomy, meaning that we are introducing some autonomous movements of the robots. The robot is going to be able to perform some trajectories and some movements by itself in order to help the doctor, because either because of delay and like the limited bandwidth, or because some movements are really complex, doctors are often not very precise in what they're doing, and obviously we can control very precisely our robot, so we can help what the doctor is doing. So we are also working on a shared control between the operator or the doctor controlling the robot, and the robot itself deciding which trajectories to do. As you can see, we have a lot of different phantoms, a lot of different dummies. Most of them are related to abdominal, the abdominal cavity and abdominal dummy. You can see here, this is an entire section of an abdomen. Inside this, we have a liver, just like one of those. And we also simulate the fat and the skin of the patient. You can see they are very flexible. really resemble and they feel like a human abdomen. We also use small dummies with different shapes in order to assess how different people are able to recognize different shapes, right? So like by just looking at the pressure response, some people are able to, for example, know that this is a round shape and this is a square shape, this is hard and this is very soft and squishy. And then we are really interested in like how the robot can help people understanding what they're touching by doing motion or by predicting the answer. And yeah, that's basically what we are studying regarding teleoperation. So I will just go back to David.
Yeah, thank you. And yeah, if you've got any questions for Leo, leave them below. We can answer them at the end. But before then, I definitely want to see how well these eggs are getting cooked. So I'm going to add you back in, Greg, and let's find out.
Hello, back to the kitchen. And as you see, our eggs are coming close to being ready. Of course, cooking here is taking slightly longer than for human. And the reason is the robot is in a social space. In the kitchen, people are around. Therefore, to keep others safe, we have a limited speed on the arm if we do not have a cage like around the robot. Therefore, everything is slower. So that's another challenge in robotic cooking. But the eggs are coming to be ready. So if anyone's hungry, the eggs are going to be here. Thank you very much. I will put it back to David.
All right, thanks, Greg. And I'm going to leave you on screen, but also bring Leo back in so we can have some questions going on here. So if I see some here, very observant point first up for our cooking robot. That pan does have a short handle because I've been down and see it recently. What is that, Greg?
So the pan has a very short handle because it was cut off, of course. And the reason why it was cut off was that we wanted to do everything very quickly as a prototype. Therefore, we are using just one hand, which is also moving the pan around. And of course, control is not perfect here. So to prevent the pan from getting stuck, we have shortened the handle.
Yeah, and I'll fire straight in with the next question for you. So this is for Leo instead. How long until robot doctors are making the diagnoses here as well?
So I've already told you that we can introduce autonomy in the robot and we can make a complete examination in a completely autonomous way. Obviously, if you are examining like not real patients, but phantoms and dummies, there is no safety issue. But when you go to real patient, then if the robot by any chance is going to injure the patient, at the moment we do not really know who to blame who to blame for the injury. So technically speaking, is just a low point of view because we have the technology and we can just gather data and then run a classification algorithm to discover if the patient probably has cancer or not, for example. But we need laws to oversee the functioning of those operations. And at the moment, we like having doctors because if they make a mistake, it's obvious it's their fault. So yeah, it's literally not a technical challenge, it's more a low challenge.
Yeah, and then next one, I'll go back to Greg, actually, quite conveniently. Have you eaten these eggs before?
I must admit I did, and I ate quite a few of them. And I even know my favorite setting for the robot to do the eggs exactly how I like them. And everyone actually has a good laugh that I know a conductivity of my favorite eggs. So yes, they are definitely eatable and they are very good.
Nice, and we might have to try them out soon as well. So we've got just a bit of time left, so this question's more for both of you. Will this eventually put all chefs, all doctors out of a job? Let's go to Leo first.
In my opinion, no, because at the moment, for example, we use share control in order to add some fine movements in order to help the doctor. We are now really focusing our research on doing the entire diagnosis, and I see robots as like possible helper that are gonna allow doctors to do a better diagnosis and diagnosis in far away and remote places, especially in the case of teleoperation. But it's not gonna substitute the entire job of a doctor, even because like the interaction with the patient is really important, and I don't really know how people could react in having to deal just with a robot without any person on the other side. So yeah, I don't think so. I think they're going to be a wonderful tool, but not a threat to any doctor.
And yeah, Greg, similar thoughts?
So I think we are very far away for replacing like a very good restaurant chefs, but like everyday meal, everyday breakfast, we should be able to do it, which may not be very important for average person, but if you are an elderly person and you don't need to go to a kitchen, or if you just go for a burger to like a fast food, there's nothing which stops it from being prepared for a robot. Of course, humans will still need to like actually have the human touch or the heuristics and intelligence. So I would think about it more like leveraging your skills and your time rather than replacing everyone.
Yeah, makes sense. Then I'm going to just put on one final question from the YouTube chat. You touched a bit there, but what would the experience of being examined by this robot doctor be like, and would you be okay with that?
Well, like personally, yes, I would be okay with that. But it's because I know the technology, and I know, for example, that we have force sensors, and if the robot tries to exert a force which is too high or over a given threshold, the robot is just going to stop. But I completely understand the point of view of people that don't really know how robot works, and they are concerned about this robot just kind of like going through them if the contact is undetected. So like that's like we are working on sensing technology where we are always putting an extra layer of safety in our code, but nevertheless is obviously not the same as a human arm, and especially for people not that familiar with robotics and with machinery, it could be quite traumatic. Yeah, I totally see that point.
All right, so we're coming up on 20 minutes running this time, so we're going to leave it there, I think. So thank you to everyone for watching. You can switch back and forth, watch some of the other uni streams, which should be starting again at 5 p.m. Feel free to stick around. We'll be starting again with the same demo at 5, see what goes right, what goes wrong in the next one. And yeah, just to finish off, I think, again, I'm going to leave you with a view of the eggs. But yeah, thank you for watching. Bye. Hello, welcome to Robot Lab Live. This is stream 3 from us, coming to you from the Bio-Inspired Robotics Lab here at University of Cambridge. So we got a couple of demos to show you. We've got a robot chef, which has been cooking scrambled eggs and omelets, and it's been tasting its eggs to get an idea of how it can improve its recipe and learn how to do that. We're also going to be showing you a robot doctor that's helping out real doctors to examine patients that they're not even in the room with, so potentially from the other side of the world. And then we've got some time at the end to answer some questions as well. So if you're watching us on YouTube and if you have any comments, any questions, any suggestions, you can leave them down below. We will see them real time and we will be able to have a go at answering them as well. So yeah, ask whatever you want. Before we kick off though, I want to show you what a bio-inspired robotics lab does. So here's some examples of recent projects that we've been getting up to. Displays. There we go. So we've got a passive hand that's not moving at all. I'll try playing this a different way. There we go. All right, not going to show you that video. Instead, we're going to go straight on. There we go. I think my internet's working out. We're going to go straight on to having a look at our robot chef. So we're going to move over to Greg, who's currently downstairs in the kitchen. So I'll add you in. And Greg, so.
Hello, everyone, and welcome to the first presentation of our lab. And the presentation is about a robotic chef. And the project is to copy your favorite eggs. So I will start it so it can start cooking when I'm talking about the project. And the idea of the robot is you cook your perfect eggs, the eggs you like. And then you would give it to a robot, and the robot would sample it a lot with conductivity sensor over there. Taking a lot of samples and running statistics on it, we can tell how much salt you like, how much mixing you like, and even how fast you heat the eggs, because it's also affecting the how big the parts of the egg are. And then the robot proceeds to try to cook its own eggs. And after cooking it in the manner we are showing here, where I need to help him out with turning the heat on, it will then again sense its own eggs and run statistics on it to know how much mixing and how much salt is done, and then use a feedback loop which would adjust the time, how long it presses salt, how much breaks it takes between mixing. It may request like changing a heat level, etc. And after a few iterations of those, we are showing that the eggs look similar to your perfect eggs. And also our hard statistical measure of these eggs are also going to the amounts you like. After the learning is done once, you can have your favorite settings, come to the lab, or hopefully in the future to the home, run the robot on your favorite settings, and have your eggs with completely no work. And the project is kind of a start of trying to make a robotic kitchen work, which has many challenges, starting from handling objects. Some objects could be slippery, like meat or fish. Some objects can be very delicate. So imagine like handling maybe a broccoli, which you shouldn't squeeze too much, or an egg. Then another challenge is to actually make the robot sense what's it doing, so it has a feedback loop. So imagine you are cooking in the kitchen, but you are completely blind without any feedback. And it's not only a visual feedback, it's also a smell, which we are trying to give to a robot. its sense of temperature, and not only in our skin, but we also know temperature just from being around. There is also a taste, which you can just sample what you are cooking while in the kitchen. And another thing you may need to add for a robot is all the social stuff. So what do you like? What people do you cook for like? What spices you like? Is it like in the morning? Would you eat something different in the morning, at night? Another thing is intelligence the robot needs to have. So, for example, can you give a robot a recipe which would then incorporate in the kitchen, or can a robot kind of develop some heuristics? So, like, it needs some symbol grounding, what it means that eggs are like mixed enough or not mixed enough, and there are many more challenges. As you see here, we have even too much heat for this mixing speed, and we are actually limited on mixing speed, which is another challenge. That if your robot is in kitchen, either in your house or in restaurants, there are likely quite a few people around, and we don't want to have a cage around it, so we may need to slow it down, maybe have like a light barriers, anything similar like this. So the cooking process will take a few more minutes. I will put you back to David, and we will be back in a few minutes to see effects.
All right, thanks, Greg. Gonna try and change the running order a bit and see if I can play you that video that I just couldn't do. So let's give this another go. Here we go. So this is the kind of thing we see in the lab. We see a passive hand that can pick up objects without being sent any particular commands. Here's a finger with some embedded sensors that's learning about its environment, but is still soft and flexible. There's some examples here on how seeds fall to the ground from trees, how the shape of those seeds might affect that path, and how we can predict that from the shape. And then a similar thing for dispersal on water, so looking at where that path is, even whether we can control that path. And then we even have a robot that tries to harvest some lettuce as well, and hopefully we'll see that happen just there. All right, so we will be checking back in on Greg in a bit to see those eggs slightly more cooked. If you have any questions you want from him, leave them down below. But before then, we're going to jump across and see how robots can help doctors out using a process called Teleoperation, where a doctor at a screen can send instructions across to a robot that's in front of a patient somewhere, which can return real-time data back to the doctor. So just opposite me here, I'll give you a better view. We've got Leo. Let's add all of your cameras in, and it's over to you.
Yeah, thank you, David. Well, let me just, right. Thank you, David. And I do run some project about teleoperation in the Bio-Inspired Robotics Lab. So teleoperation, as David already introduced to you, is the process of controlling a robot basically in any other environment which is not physically connected to the environment in which you are operating. It can be literally anywhere in the world, because we can use internet connection to transfer the command and information. In my case, as you can see, is in the other table. The important thing about teleoperation is there are two different codes, two different programs running. One is called the leader, and is running on my computer, and is the one giving the motion commands and the orders to the other program, which is in the robot, and it's called the follower. It's called the follower because it follows anything that the leader is telling to do. You probably have heard of commercially available teleoperation system in surgery. The most famous one is the Da Vinci by Intuitive Surgical Robotics. But what we are trying to do is to create a teleoperation platform for palpation. Palpation means touching. The sense of touch is really important in medical diagnosis, especially for abdominal and ventral palpation, which is basically the doctor touching your abdomen and trying to understand why do you have pain, and if there is any abnormality in what the doctor is feeling. So well, you can see that I'm here at my desk. I'm nowhere near to the actual robot, and using my keyboard, I can actually control it. So I can, for example, make the robot go up a bit. I can change the position of the robot, and I can press down. Now, when I press down, you can see here on my screen, theoretically, well, theoretically, it's not working now, but I should be able to have some feedback on my screen of the sensor. Well, I will just try to run it super fast. Actually, it seems like it hit the patient, which is exactly what we don't want to happen, and it shouldn't happen. But yeah, so what happens normally is that you operate, you do your normal operation on the Phantom, which is the soft dummy right under the robot. And then when you finish the operation, you just lift the robot, and the robot goes back to the starting position. What happened right now is that the robot decided to shut itself down and to push down. And I'm really sorry for that, because it really shouldn't happen. We have a sensor that it's exactly used for not letting the robot crash into the patient, but I think the sensor disconnected somehow. So we add this little bug. I guess I just hand over to David at the moment.
Yeah, there you go. If you wanted some proof that we're live, there it is. Thanks, though. Any questions on that, do put them down below. We can get to them in a second. Before that, though, we definitely need to see how our eggs are getting on. So, Greg, I'm going to add you back in, and the floor is yours.
Hello. So going back to eggs, I actually also had a little bit of a problem here. The heat was too much. I forgot to turn them back. So they are slightly burnt just on the bottom. But as you see, they are still coming to be more and more eatable. So the process is going for longer, as we are limited with the mixing speed of the arm, etc. So you definitely can eat those eggs, and they are very good when process is parameterized well. And hopefully we can have those in kitchen sometime soon, and cooking something more than eggs. So thank you very much, and we can go back to David.
All right, thank you, Greg. So just before we get to questions, I think we want to jump back to our robot doctor, which is behaving a bit more this time. So let's add you back in, Leo. And do you want to update us on what's happening here?
No, yeah. So what happened was that for some reason the sensor wasn't giving data, so the robot didn't know that the touch had been made. So as I was saying earlier, you can move the robot in any direction you want, and once you have moved and finished your operation, you are just gonna basically tell to the graphic user interface that you have done, and the robot will just go back to the initial position, and you can start a new diagnosis on a new patient. Yeah, that was it. Thank you, David.
All right, thanks. So I'm going to add Greg back in as well, so we can have a look at some questions. Greg in the middle of cleaning.
Sorry.
We'll direct the first question at you anyway, Greg. How does the robot know when to stop mixing these eggs? Is there a sensor in the spatula? I know there's a sensor at the top there, but yeah, what's going on there?
So as comes to timing, we have a kind of a standard way it mixes, and then the parameters how long it sleeps between mixing. And this parameter, when the robot cooks the eggs with current parameters, it will then sample it with conductivity sensor, run some statistics on it, and see if it's mixed enough or not enough, and adjust this sleep time. And this approach is kind of very crude, but it was made for very important reason, that we are limited by safety reasons. We don't have a cage around. So there is like a maximum speed you can run an arm when I am like here putting hands around and so on. So the sleep time is adjusted by the robot by tasting the eggs it cooked previously and adjusting it. And as comes to space, we do not have a feedback for like a spatial mixing. It's just pre-programmed. But I agree, it's exactly one of those bits we are missing in robotic cooking, where we as a human, we understand where is the edge of a pan, why the robot doesn't, and that's what we definitely want to add one time to our robot.
All right, thanks. And I'll give a question to Leo as well now here. Again from YouTube, do you think teleoperated tools like this could be used to improve medical access in remote regions, say?
Well, that is exactly the main reason that we think is a good research field. It's either like when I think about remote location, I think about any location in which is not any location which is not accessible per se, or which is quite dangerous. So let's suppose that you have explorer went into a cave and he injured himself, right? Going inside the cave is not really the safest option, but if you have a robot that is able to be displaced there and then do a diagnosis, that will solve the problem, because even if something happened, we are just wasting a robot, which is very expensive, but it's not like a human life. So that's exactly the point of my research.
Yeah, exactly. So we'll take that away. And very important point here about the order of how we're doing things here. When we cut to you, Greg, there were some eggs already in a pan, not mixed yet. Could they have been mixed? What had happened just before we came to you the first time?
So what if I like my eggs mixed before cooking? Well, you just mix them before cooking to the hot hob. It's a very modular thing, and it can be adjusted a lot. So it's not a problem. But what we know is that you actually need to still mix during cooking, because the eggs cook very much from below, and you would just end up pretty much with a fried egg. So you still need some form of mixing probably during cooking, but it's not a problem to change it.
Yeah, it's a good point. So we're coming up on 20 minutes, but I'm just going to give us, I think, one more question to finish off on. So this is for both of you, I guess. How long did these take to program to set up everything? So Leo first, how did that work?
You mean setting up the entire platform? So we had to rewrite the communication protocol between robot and leaders, between follower and leader, and that took quite some time. But the actual control of the robot is pretty straightforward, in the sense that we communicate to the robot the position in which we want the end effector, which is this part of the robot here, to be, and then all the firmware of the robot is already provided by Universal Robot, which is the brand that the company that we use. So I would say the setup of this robot of this platform took roughly 3-4 months, and then like 2 more months to have a clear idea of the experiment that we wanted to do, and then to actually do the experiment. So yeah, I would say like in total 5-ish.
Yeah, and what about you, Greg? How long does it take to learn to cook eggs?
Around 3 weeks, I think. The movements itself are easy. The big problem with the robot is that it's not completely accurate, so we need to give up some accuracy for a speed of the arm movement. And this actually took the most of this time, and it was of course including to make the sensor work and also the feedback loop.
Okay, thanks. So we're a bit over 20 minutes now, so I'll leave it there. Thank you for watching. You've got one more chance now to go and see the other team's demos, which should be starting at about 5:30. Choose any other uni, watch what their robots are doing as well, or feel free to stay on and watch us again starting at 5:30. Otherwise, though, thanks for watching. We'll see you soon. Okay, welcome back, and thanks for joining us for the last stream of the day, here coming to you from the Bio-Inspired Robotics Lab here at the University of Cambridge. So we've got half an hour left, we've got some demos to show you, and you'll be seeing coming up a robot chef, which is cooking scrambled eggs and omelettes, and is improving its meal and its recipe by tasting what it's been cooking. We'll then show you a robot that's been helping out doctors by sending data about a patient that it's examining to a doctor who's not even in the room or maybe not even in the country. And then we've got some time for some questions from you at the end as well. So if you're on a YouTube account and you're watching us on YouTube, if you put any questions, any comments down below this video, we will be able to see them real time. We can give you any answers and anything you want to know to that. So before we get properly stuck in, I'm just going to give you an idea of what a Bio-Inspired Robotics Lab does with some recent projects here. So our video is not playing again. So we'll give up on that and we'll actually go across to our first demo and I'll try and get it working in the meantime. So that's our robot chef. Hopefully Greg is currently downstairs with a robot that started cooking some scrambled eggs. So Greg, I'm going to add you to the stream and it's over to you.
Hello everyone and welcome to a first presentation. Hello everyone and welcome to the first presentation. The robot is not cooking yet, but it's just about to start. So you can watch its operation while it cooks, while I will explain the project. So the reason for this project was to copy your favorite scrambled eggs the way you like them. And to do it, we of course need your favorite scrambled eggs. So you would cook your favorite scrambled eggs and show it to a robot, which would then sample them with a sensor over there. It's conductivity sensor, so it's checking how easy it is for the current to flow through the dish. And if we take quite a few of those samples and run a correct statistics on them, we then can have how much mixing you like, how much salt you added, and how much you were heating it when cooking. And the reason for the project was to try to kickstart the robotics in kitchen a little bit, which has many challenges. So one of challenges is the handling of the food itself. Some foods, imagine like a chocolate or very well cooled butter, are hard and stiff, and they can be handled easily. But if you imagine like a wet meat, and I forgot to turn on heat, which we will of course fix on this. So coming back to handling some materials like a wet meat or like a fish are slippery, so we need to grab them completely different. And other things are delicate, like imagine handling a broccoli, for example, or an egg. You can squeeze them too much. Another problem is to put actually intelligence in the robot. So the thing with intelligence is that we humans have a lot of experience with objects around, both with like furniture in our kitchen and food, and we actually use heuristics to, for example, say if these eggs are cooked properly or not, and we have solved so-called symbol grounding problem. So we know when eggs are properly cooked and why not. We understand them. Another intelligence thing is, again, with symbol grounding problem. So how to actually program the robot so it will know when the pan ends, so it wouldn't steer it like outside a pan. It should just know where. There is also a lot of more social challenges, like what do you like to eat? what people you cook for like to eat, what spices you like, etc. What time of the day it is. Perhaps you would eat different things in the morning and on the lunch. So there is many of those challenges, but why I am doing this particular project is because I think the biggest challenge is that the robot is basically blind. So of course we can add camera, so it would have a visual feedback as we do. But then what we do with a tactile feedback we can have with our hands, which helps us with handling. What do we do with smell, which is telling us a lot about the dishes we cook. Then robot doesn't have a taste. So during cooking, it can't just go and taste out if it's going good or bad. Well, now it kind of can, but it's still at the very early stage. So as you see here, the robot cooks eggs. And in order to match them to your perfect eggs, it would just have all this information it gathered about your perfect eggs. It will cook those eggs and sample them again with same sensor, run this same procedure, see the difference between your eggs and the eggs it cooked, and hopefully adjust some parameters. Like the easiest one is the time of pressing the meal, another is how much mixing we do, etc. And that's the finished presentation here. We will come back though to see how the eggs look like in a few minutes. So back to David.
Okay, thanks, Greg. And yeah, as he says, we will be back to see them once they're a bit more cooked. But in the meantime, if you do have questions or you want to know anything about what's going on there, leave them down in the comments and we will be able to see them. Whilst they're cooking, I'm going to give that video another go. I hope I've sorted that by now. So let's have a look. That's clearly a no, so we'll give up on that, I guess. And instead, we'll just have a look at how instead robots can help out doctors to examine patients using a process called Teleoperation. So where a robot can send data to a doctor that's sitting in front of a screen, who can in turn send instructions down to the robot and examine a patient real time in that way. So to have a watch at that, we're going to put over to Leo here and see that process. It's over to you.
Hi everybody. Thank you, David. Yes, David already explained what I'm doing is teleoperation, and in teleoperation, we have two different processes. One is the robot that you can see on the screen at the moment, and one is what we call the leader, which is how I'm gonna control the robot. And in this very moment, the leader is on my computer, and technically speaking, those two processes could be in very different places. So with any computer, anybody could access the leader and could control the robot and perform any type of medical examination. So if we can see my screen at the moment with the top camera, you can see that I'm seeing a black screen, and with my keyboard, I'm able to control the robot. You can see that the robot is quite slowly moving. We have all sort of phantom here. We have levers, we have abdominal phantoms, and whatever. And you can see in a second that if I touch something, my screen will start showing me the haptic feedback. So it will start showing me the pressure and how the pressure changes as I move the robot around. With this, we are able to actually study different human strategy to complete tasks such as reaching or recognizing different object or moving object. And we can analyze how different conditions, so different phantom, but also maybe different delay between the robot and what you're seeing can influence your strategy and your accuracy in performing the given task. Yeah, that's everything basics about teleoperation, and I'll give it back to you.
All right, and it's definitely time now to see how those eggs are getting on. So I'm going to put Greg back on screen. How's it going?
So the eggs are going quite good. I think they will need a little bit more time, which is caused by another challenge to the robots in kitchen, which is they work around people and we do not have a cage around them. So the safety actually limits how fast it can go when I could like theoretically put like a hand or anything there. So the eggs are doing very well. You can have them cooked to your own liking, although it still takes quite a bit of time. So thank you very much.
It's over to you.
Hi everybody. So robot doctors can already make diagnosis. It's not a problem of technology because we already have the doctor here sensing and sampling the data, and we could easily run an algorithm in order to like achieve diagnosis. The problem is that if the algorithm or the robot make any mistakes, so they hurt the patient or they give the wrong diagnosis, at the moment we do not have any laws that are going to take care of that and point at the person responsible of that mistake. So I will say that technically speaking, we could already make diagnosis, but in real life scenarios, it's not going to happen soon because we do not have the environment around that.
Yeah, thank you. And then we'll ask one to Greg as well, who's still there with our cooking robot. So what else can it cook? Is it just eggs or do we have more options?
So this particular robots actually can do only the eggs, but we had a robots in our lab which were doing also omelets, which were also teaching itself to adjust to a user preference. There was also a project with a tactile sensor which was estimating if you were cooking something, for example, potato, it would like touch it out if it's actually cooked or not and estimate how much longer you need. But the robots are currently task specific.
Okay, thank you. And let's see what else we have here. More a question about our robot here. A word you mentioned there. What's a phantom?
Right. So a phantom is basically a dummy, an object that will simulate a human part or a human body part. So well, this is easier. This is a liver phantom. It's basically a liver-shaped, silicon-based soft object. You can squish it, and like the mechanical characteristic of this phantom are pretty close to the actual liver. Even though it doesn't do anything, it's just there, so we can touch it in the same way that a doctor will touch a real liver. And in the case of this guy here, in this one, we have basically a section of the abdomen. So we have the skin, we have the fat simulated inside it, and we have one of those livers inside this in order to simulate internal organs. So yeah, basically it's the easiest way to do experiment without having real patients under the robot.
All right. And more questions here that we sort of hear. If people know you work in robotics, will this eventually put all chefs, doctors out of a job? So Greg first, how will this affect chefs?
So to be honest, I think we are very far away from chefs from like a good restaurant. But as comes to like everyday food, it can change a lot. Or could you imagine like for elderly people, if they need to have a breakfast, now they could do it with a robot, not needing additional assistance, so they can be more independent. And also, if you think about like a fast food, we see no problem with like fast food being assembled by a robot.
Okay, so let's get rid of that. We've got a few minutes left. So what I want to know as well, how do we stop a robot doctor from turning evil?
Well, that's a real question. A robot doctor, especially in teleoperation, is just a tool. It just exactly does what you are doing on the other side. So provided that we should not have evil doctors operating the robot, I think there is no really a chance of a robot doctor being evil. For safety, we have safety measures in the robot, in the sense that if the robot is pushing too much, it's going to stop itself when the recorded force will be over a given threshold that we can set. So, like safety-wise, we have a lot of layers of security in the robot. Evilness, it's just a tool. It's literally, it's like a big mystery that can move itself. That's it.
Yeah, and then finally, to finish off our streaming for today, the final question, Greg, have you eaten these eggs before?
Oh yes, I have tried it, and I actually have like a favorite parameters for those eggs. The only one downside is that you actually need to know your perfect eggs in terms of conductivity, which may be not very handy. But yes, you definitely can eat those eggs.
Okay, good to know. So what I'll leave there. Thank you for watching. Thank you for getting involved. I think just as a final view, I'll show you how those eggs have cooked just to finish off. But otherwise, thanks to Leo, thanks to Greg. Enjoy the rest of your day.